have to bring the lot of hands-on project. Okay, so the level 1 we have to discuss the core peripheral mastery. Okay, like how to build one project. Okay, so in this project, so in this complete hands-on, we have to use the STM32 microcontroller. Okay, so you might be having the different series. Okay, you can implement it in your series, what the exact microcontroller series which you are having. You can implement these projects. Okay, first of all, the level 1 of core peripheral mastery. So with the help of only registers, we are going to be do one project. Okay, so it is completely based on the GPU drivers from scratch. What is the project we are going to be implemented today is, so we are going to create own GPIO drivers from the scratch. That means without HAL library. So we are not going to use any HAL library. With help of only registers which is present in the microcontroller, we have to write a data pattern. Okay, like we are having a LEDs. Okay, so in logical codes, we know this one. In binary code, it is in the form of 2-bit binary or 3-bit binary code. Okay, if it is a 1 bit, okay, you can able to represent or 0 or 1. Okay, it is in this 1-bit form representation. If it is a 2-bit representation, you can able to represent the bits called 0001, 1011. Okay, so up to 3. And if it is a 3-bit representation, you can able to represent up to 7. Okay, if it is a 4-bit representation, you can able to represent up to 15. Okay, so up to this, you can able to representing the bits. Okay, so you just think it, guys. So this is the pattern we have to use today. Okay, we have to represent in form of 2-bit. So you people are going to be implemented the either 3-bit or 4-bit pattern. Okay, so what we are going to be do this, we are having using one LED. Okay, so the component required, I'm going to be tell you that. Before that, what is the pattern we have to do it on today's lives. Okay, so the thing is, you should have one microcontroller. So the microcontroller, which is we have to completely use the STM32. Okay, STM32 F411 RE microcontroller only. We have to use the STM32 F411 RE microcontroller. Okay. So you might be having the different series. So that's not the problem. You can use any of the microcontroller in the STM32 series. So if we are going to be interface the LED. Okay. So for I need to do the logic of 2-bit. Okay, so because in STM32 itself, it is having an inbuilt LED. Okay, STM32, it is having an inbuilt LED. So that inbuilt LED which is connected with the port A of 5th pin. Okay, port A of 5th pin. So how do I see this one, whether it has been connected, which is connected in this bit? So you have to see it on your data sheet. Okay, you have to see it in the data sheet. So I'm going to be show you that. Okay, because previously we discussed in the ATAS concept, the inbuilt LED which is connected, okay, in your processor or okay in your controller. So it has connected, so it is having the multiple pins, right? So it is having a multiple pins. So the port A of 5th pin, your inbuilt LED has been connected with the port A of 5th pin. It has been connected. Okay, but I'm not going to be using this inbuilt LED. Okay, that is the thing. I'm not going to be using the inbuilt LED. I'm going to be take 2 external LED. Okay, we are going to be take the 2 external LED. So this is LED 1 and this is LED 2. Okay, so what I'm going to be implemented here, it is I'm going to be implemented the data pattern. The data pattern means, so like the code, okay, like the pattern, so the 2-bit pattern, whether it is 0 0 or 0 1 or 1 0, so that logic we know that in digital form. Okay, so that logic we are going to be implemented in code. Okay, so this is the data pattern we are going to be implemented to blink the LED. So what are the components we need to require this? So yes, it's obviously the bare metal programming. Okay, so yes, guys, the thing here it is for what are the components you must be required? The STM32 microcontroller, and you need two LED. Okay, and for LED, which is required the current limiting resistor. Okay, because in STM32 power supplies which is having a 3.3 volt and it is having a 5 volt. Okay, the power supply, the maximum supplies which can provide is 3.3 and 5 volt. And if you're taking a LED, the LED operating voltages are, okay, if you just look out, if you just see it in the data sheet, what is the forward current? Okay, and what is the voltage? So what is the forward voltage? You have to calculating the forward voltage and forward current. Okay, so it is very small. So you just compare, not even you have to look out this forward current. You just compare with the voltage. So voltage is, it is only like a 1.82, the operating voltage, which is 1.82 2.2 only. Okay, just think it, if I'm just giving above this voltage, it will be get burst. So for that, we have to implemented one resistor. So the current limiting resistor. So what is the value of resistor I need to be choose? For that, you have to use the Ohm's law. Okay, we have to use the Ohm's law. V is equals to I. What is the forward voltage and what is the forward current? Based on that, you have to what is the forward source voltage? So how much voltage you are taking from the microcontroller and how much voltage it can able to sustain the LED, and what is the current which is flow through this LED. Based on this parameter, you have to find it out the resistor value. V is equals to IR and R is equals to V by I. Okay. So how can I easily find it out this value? What is the source voltage which you are providing actually from the microcontroller? For example, if you are providing a 5 volt, for example, 5 volt you are providing the LED. Okay, the LED voltage, the range is 1.8 to 2.2. For I'm just giving a 2 volt. Okay, and you have to look out this current forward current. So if you are confusing where you are taking these and all the datas, so you don't need to be worried about that. If you want to be see this datas, okay, you just go to this data sheet. So you just put LED data sheet. So what is the size of your LED? Okay, you might be using a 5 mm LED, 2.5 mm LED. Okay, here I'm using a 2.5 LED. Okay, you just go to this and go to the data sheet. So many data sheet is going to be provided for you. So through that you can able to draw everything, you can able to do it. Okay, this is what's, and if you just see this one, yeah, it is telling like forward current is 20. Okay, here they have been providing the forward current is 20 milliamps. Okay, the forward current is 20 milliamps. And here they have been given the forward voltage. So forward voltage is typically 2 to 2.5. So here the forward current is 20 milliamps. So this is the very important parameter you are going to be see. Okay, so LED is diode, right? So it's like a diode. Okay, so forward voltage you are going to be take the data. So 2 to 2.5 we can take it, and forward current is 20 milliamps. Okay, based on this you are going to be calculated. So 0.20 milliamps, right? So that means 0.0 amp. And after this 3 volt divided by 0.02, and you will get the value like so which is about 0.001 amps, like sorry, exactly. So we will got some value. Okay, so we'll got some value, so we'll get the exact value, not 0.001. So because we are going to be find it out the value of a resistor, so you people are going to be tell the answer what is the value of resistor. So that value of resistor we are going to be implemented on here. Okay, so that value of resistor we are going to be implemented on here. Okay, so that's all the thing it is, guys, here. So I'm going to be implemented. For example, oh yeah, Shakshikant, thank you so much. The answer is 150 ohms. Okay, so 150 ohms. So thank you, guys. Yeah, Varnit Gupta, thank you. All the people are telling the answer. Yes, it is a 150. So yes, I've got the answer. So Sunil, super, thank you. Shakshi Khan, Varnit Gupta, Sunil, thank you for all the people, guys. And here I just simply add this resistor on here. But the thing is, the 150 is the accurate value. Okay, it will be giving the super brightness. Okay, if you want to be reduce some brightness, you can also use, because in resistor there is a specific resistor which is not available. Okay, like 140, 170, 180. We can add some and minus something else. Okay, if you are getting value, you don't minus all the time. You can add the resistor value somewhat, 30, 100 kind of value you can able to add in this kind of LEDs. Okay, if you are getting a 150 ohms, you can use 220 ohms. Okay, and you can use 330 ohms. These are the things which is preferable. Okay, at the same thing, you shouldn't use 1K, 2K, 4K kind of resistor. You shouldn't use. Okay, so if you are getting 150 ohms, you can use these other things which is preferable. 220 ohms, 330 ohms are preferable. You can use this values. Okay, you can simply connect this thing. Okay, what you are going to be implemented, guys? Simply you are going to be take one STM32 microcontroller. You need one two resistor, because I'm going to be connect the, and finally I need a LED. Okay, so no guys, so you cannot use, cannot. Okay, so because when you're going to, because this is the accurate value, you are getting accurate value. You are just getting the data from your data sheet. So it is correctly telling, which is exactly telling. So this is the forward voltage, this is the forward current. So when you're trying to use above this value, not going to be affected. It's just affecting the brightness only. If you are using 150 instead of 150, if you are using a 220 or 330, it's just affecting the brightness. So it will be mild. It will be somewhat less brightness comparatively the 150. But if you are using less than, if you're using less than 150, definitely it will be causing some problem in LED. Okay, that is the scenario. Okay, here you should have this resistor, current limiting resistor and LED. So here you are going to be use two LED, two resistor. Okay, so now we will directly go to this one, guys. So I'm having the program code. So how to get these and all the data? Okay, reference manual to be write the code. Okay, so I just open up the data sheet and reference manual to write a code for this. So the data sheet is just for to be understand the pin definitions and block diagram of this one. Okay, and what is the purpose of reference manual is, the reference manual is completely write the code. Okay, it helping you to be write the code from the scratch. Okay, that's what we are going to be use. In this data sheet, it is helps to be understand the what is the block diagram of this microcontroller. Everything you can able to understand here. So this is the internal architecture of your microcontroller. Here, if you want to be use the inbuilt LED, you are going to be see this block diagram and all. Okay. So yes, today I'm going to be use the external. I'm going to be using the external LED. Okay, both are external LED. So what the pin I'm going to be use? Okay, before that we will see this. How many? What are the pin outs in STM32? We will see. Okay, STM32 pinouts, if you just put, you can able to see this. This is the pinouts of the STM32 F411 RE microcontroller. Okay, it is having in the form of port A, port B, port C. So port A, it is having 0, 1, 2, 3, and kind of pins are there. Here I can use whatever the pin, okay, and I'm going to be configure my LED. Okay, I'm going to be toggle my LED on and off by the data pattern of 00011011. Okay, here I'm open up this one. So today I'm going to be use the two LED. Okay, for that I need to be I need to be choose the pins. Okay, I'm going to be use the port A of 0 and port A of 1. These two pin have been used, I'm gonna be used for to be connect with my LED. Okay, so simple thing, so you can easily do. You can also connect to the 4 pins. If you're going to be connect with the 4 pins, you can take a PA0, PA1 and PA2, PA3. So you can use the 4 pins if you are going to be implemented the 4 bits 00001111. So like that. So the LED is going to be blink this format. Okay. So yes, guys, and I chosen this pins. That is a port A0, port A1. Okay, so how can I start to be write this code? So here I've been having this code. Okay, it is easy to be explained to you. Okay, first of all, if you just see this one, so everything I'm going to be tell you with this a clear explanation only, guys. You don't need to be worried about that. Okay, here if you just see this one, I'm going to be make it somewhat large. Okay, first of all, you are going to be use the header file. Okay, so this is completely bare metal programming. We are going to be using this header file. Okay, why we are going to be use this header file? So stand int dot h. That means you specifically implemented this unsigned off integer. So you can, if you are using in your program, if you're using in a here I'm not using, here I'm just simply use with the help of the macros. Okay, hash define. So you can also use this one, or else if you want to be implemented this address. So why should I use this address? So everything we will discuss. Okay, if you're using in a code like unsigned off 32-bit, because in normal C programming, if you are writing, you write the code in the form of integer, int. So it is easy. You see, if you are developing a software, so they won't be consider the size and all. So if you are designing, if you are going to be developing this code into uh, any module, so we are going to be concerned. So we are, if you are writing a code for your microcontroller, we need to be concerned about the size. Okay, we know that what is the size of integer? It is a 4 bytes. Okay, so if you are going to be, you should be use the exact size. Okay, so you are going to be concerned about the size that whenever you are going to be write a code for your microcontrollers and all, because it is memory is going to be waste, you will lose the data because of no insufficient data storage. Okay, so here instead of you are going to be use the integer, you have to use this is unsigned. U means unsigned. Okay, so sorry for to be acknowledged, guys. So this is the tool is called as an STM32 Cube ID. Okay, so this software name is called as an STM32 Cube ID. You can install through our previous videos, and YouTube also it is available. Okay, so that is a U. U means unsigned integer, guys. Okay, U means unsigned integer. So what is the meaning of unsigned integer is you can only use the positive numbers, positive addresses. Okay, so it is not, if you are using normal integer, it is possible to get the minus and positive numbers. But if you are using an unsigned integer, it can take only the positive numbers, and 32 which you are indicating, it is a 32-bit processor. Okay, if you want only the data you are going to be acquired, it is only required 8 bits. You can simply use use 8 bits. You are just saving the space. Okay, so likewise we can able to do with the help of this unsigned instead of integer, instead of char, instead of doing like this, you can simply use this type of data types. Okay, and for to implement, if you want to implement this, you have to head a file called this. Okay, so we can use specific bits, or we can configure unsigned integer if you want to be configured. You just use this header file. You're going to be use this header file. That's what the purpose. Because if you don't want to be use the specific things, you can simply use the stdio.h. You don't want this, you just simply use the stdio.h. If you're only you're going to be using this int char kind of thing. Okay, but I want to be use this specific bits. I just using this concept. Okay, and here if you just see this one, guys, here I've been written some addresses. Okay, what are those? Okay, you can easily understood this concept. Simply you just open up the data sheet always. Block diagram is very, very mandatory because you can't able to use the what can I say? You can't able to visualize the structure which is present inside this one. Okay. So yes, guys, so today we are going to be implemented the 2-bit. Okay. And yes, so this one, page number 15, which is telling like internal structure of this block diagram, how it has been connected with each other. Okay. And if I'm just looking out this, all the thing, what I have required it in this block diagram, what I have required it, I need GPIO. Because I already know this concept, I need the port A of 0, port A of 1. So who's gonna be the head? The GPIO port A, because inside this GPIO port A, I'm having the bits up to 0 to 50. I can use any of them. Okay, it's having 0 to 50. So I'm going to be use inside 0 and 1. Okay, I'm going to be use this too, because this is simple LED. It is just a digital output. Okay, so for that I don't require these and all the stuff, like I don't require timer, use art, and these and all the stuff. I don't require it. I need only this port A of GPIO. Okay, for to be configure this time. So I am just found this. So if you just study this concept, the very, very important stuff is all the peripheral. So if you just see this one, all the peripheral has been connected with this bus. We already know the concept. In electrical circuit, all the components has been connected with wires, right? Because you have to passing a current. Here, all the components, I mean, not all the peripherals like DMA or RC oscillator or user timer. So everything has been connected through bus. Where we call here in embedded system, we call it as a bus. Okay. Here, most commonly, if you are go with this 805N or whatever it is, most commonly, so we call it as an AMBA. Okay, advanced microcontroller pass. But here it is having a two variant. One is called as an advanced high bus. Another one is called as an advanced peripheral bus. We are having a two bus. So it is most commonly, it will be look same. Okay. So whenever you want to send the data very fast. Okay, like it is very high speed bus, advanced high bus. It is advanced peripheral bus. So whenever you want to be low speed data, you can connect with this one. Yes, check with your side, Purna. Might be problem on your side. Okay. So this is what I'm going to be doing. So if I want to be configure my GPIO port A, definitely it has connected with this bus. Like if I want to be configure user 2, I need to be interface with user 2 with any sensor. It is connected with APP bus. Likewise, so all has been connected with somewhat one bus. So you don't need to be memorize these concepts. You can, if you just look out the data sheet, you can easily understood. TMA, it is connected with AHB, and timer 2 is connected with ABP1, and USART1 is connected with ABP2. It is having a different variant. You have to easily understood this concept. So if I want to be enable the GPIO specifically, because your microcontroller is all our zeros and ones. It's completely because the systems can't understand any other language. It is only 0 or 1. So based on that, it is going to be reacted. If I specifically configure the GPIO, first of all, I need to be enable the GPIO. Before that, all present in this reset condition. That means in 0 condition. Okay, we have to enable the GPIO first. Okay, if I want to enable the GPIO because all must be in 0 condition. Okay, if you just see this one, so before enabling this concept, 0, 0, 0, because it is in reset condition. So when you're going to be give the power, still it's present in this reset condition. It's not going to be give toggling. When you're manually toggling the bits, when you're manually enabling the bits, configuring the bits, configuring the peripheral, configuring the registers, then only it is going to be reacted. Okay, here I need to be enable the GPIO. Why? Because I need to be connect to the port A of 0 and the port A of 1. Before I need to be enable. Enable means 1. When I make it 1, so it is going to be enabled. Okay, how can I make it? Because it is connected with AHB1 bus. So because of this, it is connected with AHB1 bus. You just go to this reference manual. If you want to write the code, you require this reference manual to be understand how to write the code from the scratch. You just go to this one. Okay, here you shouldn't directly go to this GPIO because we have not even enabled the GPIO pin. Okay, so you just go to this reset and clock control. In this reset and clock control, you can see the RCC register. This is called as a reset and control register. Why we are going to be used this? This is the very, very important procedure for all the project you are going to be doing. So the clock is very, very important parameter. Okay, it is the first stage. If you are work on with the U or I to see whatever it is, you are going to be use this one. Use this RCC register. Okay, here you are going to be find it out what is the bus you exactly want. So I need the AHB1 bus. So what the bus I required it? I need the AHB1 bus. So here you can able to see this, guys. It is telling AHB1 ENR. We can also see this AHB1, AHB2, ABP1, ABP2. So these are ENR. ENR means you are just enable the register. You can able to see this when I over this. Clock enable register. Same thing you can also having the reset register when you want to be resetting the bits and all. So you can also do the, okay, I just come to this one. Here it is a HB1 peripheral clock enabled register. In this one, you can able to see this concept like GPIO, GPIO. So what are the peripheral which is connected with this AHB1 bus? Like, so GPIO up to H it has been connected. Other than that, it is having a DMA1, DMA2. So this DMA1 and DMA2 also connected with this AHB1 and CRC, cyclic redundancy check, also connected with this one. Okay, so also connected CRC, which is also connected with this one. So AHB1 as having this authority. So likewise, if you want to be find it out, what are the things which is connected with this ABP2 bus? You can go to this and see this ABP bus. I can easily find it out. Here I need to be enable the GPIO, guys. Okay. So because this is the very first procedure I need to be do, when I'm going to be enable this GPIO I can configure the pins. How can I enable this pin? Okay, how can I enable this pin? If you ask this question, so you can simply toggling the pin. So you just see this one, scroll down, scroll down, scroll down. So for every bit, what is enabled, what is disabled, they have been given up to 22 bits. Okay, so up to 22 bits. Other than that, all other bits are reserved. Okay, you just scroll down. My GPIO, the GPIO enable, which is located on the bit 0. So input output port a clock enable. If you want to be enable, clock want to be enabled to that specific line, you have to be enable. If you just give 1, it is going to be enable. If you just give 0, it is going to be disable. Okay, got clear? So what the concept we must know about here it is everything in embedded we simply use toggling the bit 0 or 1, 1 or 0, 1 1 kind of thing we are going to use. We know in programming language very important stuff is the pointer and the bitwise operator. So by using this complete thing, by using this very two important parameter, very two important concept, you are going to be manipulate your entire things. So here, when I'm going to be use 0, it is going to be disabled. 1 means enable. I'll just simply go to this. First of all, before you are going to be configure anything else, you have to write the address. Because each and every peripheral, it is having, it is holding some different address. If you want to be configuring a GPIO, okay, if you want to be configuring the GPIO, we need to be, first of all, we can enable the AHB1 bus. Through this AHB1, we can able to on or off can able to going to be done. Okay, we need to be write the address for TMA2, it is having address. So like AHB2, it is having address, GPIOA, everything which is having some address. First of all, you just tell that what the peripheral you're going to be configure. Okay, that address is important. So through pointer, you can also implement the address. Because pointer which is in the form of hexadecimal value. So we directly using like integer or character, which is not going to make any sense. It is not, we cannot declare the pointer. It's just a data type. So when you're using a pointer, then only we can clearly declare the hexadecimal values of address. Okay, if you just see this first thing is, the first important thing is I need to be enable the AHB1 bus. Inside this AHB1, the GPIO has been represented. So I'm just go to this ideally. IDE. So here you can able to see this open perspective and it is C or C++ or debug. You have to set your debug perspective because you need the registers and all. This is variable. You can include the variables. If you are putting a breakpoints, the breakpoints going to be add on here. So where you are putting a breakpoints. So if I'm just putting a breakpoints here, so it is going to be add on. Okay, and expressions and registers and live expressions and SFRs. So these SFR is very important thing, guys, because this is called as a special function register. So registers means it's storing a data, storing a bits. Right. So not like memory to be stored the large data, it is storing a small bits of data. What about the special function register? Yes, which is having a different address, guys. What a special function register means, if you are taking timer which is holding a different address. If you are taking RTC, that is one of module, that is holding a different address. Likewise, you are having a different address for all the peripherals. what you're going to be find it first. So you can clearly understood this concept. For this is the Cortex M4. Our microcontroller, guys, our microcontroller, it is having a processor and other peripherals has been added on here. The processor name is ARM Cortex M4. ARM Cortex M4. So mother peripherals has been added and the controller name is called as an STM32. Okay. So same thing. What are the things which is present in this Cortex M4? You can see here also you can understood this concept. This is a processor architecture. The JTAG, Cortex M4, FPU processor, MPU. So these and all the stuff, it is processor architecture. Okay, and these peripheral has been add on. It is called as an STM32. So all the control FPU. So the processor registers has been present here. The controller register has been presented here. Okay. First thing is you are going to be declare the address of his AHB1ENR. Okay. So for that you are going to be finding out the RCC register. You are going to be finding out this RCC register. Inside this RCC register, it is AHB1ENR. Inside this AHB1ENR, you are going to be enable the GPIO-A. It is just the enabling. I'm not assigning, connecting any pins, not doing anything else. So inside this process, inside this controller, simply giving one clock to enable. I just walk on with this GPIO-A port, A pin. So for that, I'm just giving one clock. Before that, you're going to be write the address. Okay. Here, you can have the different parameter declaring the address. Here we have been used the macro form. Okay. Here we have been used the macro form. Other than that, you can use the pointer structure also. If you're implementing the pointer structure, you have to declare. So how you're going to be declare the pointer? How you're going to be declare one pointer? First of all, you're going to be write the data type. Okay, here I already told you that everything we are going to be use an unsigned type. Okay, so unsigned of integer. So the point is x decimal, so it is integer and a t. Okay, and u int 32t. So it is one of the data type, unsigned integer of 32 bit. And you are going to be use the pointer variable, not the normal variable. You are going to be implement the pointer variable. Pointer variable is here, whatever the variable you can be able to use, but make sure you have to use this asterisk symbol. It is differentiating the normal variable to pointer variable. Okay, here I'm just simply putting a pointer. Okay, you can use whatever it is, but asterisk is very, very important. And you're going to be using the register name as a pointer variable. Sorry, guys. Okay. So here, if you just see this one, AHB1ENR, that is a name. Okay, don't consider the pointer name should be come with P, AHB. No, your wish, your identification. Okay, you can give. The address is very, very important. Okay, the pointer variable, whatever you can give it, the asterisk is very, very important to telling it is a pointer. And then you just provide the address. Okay, you are just providing your address because normal variable can't able to find it. So in this case, still it will be it just understanding it is a pointer. Okay, it is now it is understanding a pointer. I'm going to be again it is I'm going to be typecasting. It is a pointer integer type. Okay, I'm just declaring it is a pointer integer type. So for that, I'm just using this and I'm going to be, it is a pointer integer type. I'm just simply typecasting this one. Okay. 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 Here I've been, here if you just see this one, so here I just simply typecasted the point that is address. Okay. So here we just go with this macro. You can see this one that this is one of the name. So RCCHB1ENR. And this is the address. Okay. And this is a volatile. So why we need to be use this volatile and all? So it is going to be vary. I'm just simply telling my address and data is going to be varying. So at the time you just use this volatile. Okay. For this one, I'm just typecasting the integer type of unsigned of 32 bit. This is this is the address. Okay. And likewise, I have complete this one. And now I'm going to be enable the bit because up to 8. Okay, up to 8. Okay. So I'm just given the address only. If you want to be implemented the concept, if you want to be implemented the bit setting or resetting the bit, because till 8 I just uh, declaring the address only. So I didn't toggling, I just enabled the bits and all. So I'm going to be enable the bit. For that, I just use this way macro name. If you're using a pointer, you have to use the pointer. You just copy this, the pointer name, you just copy this pointer name and enable this one. So then we have been use the bit shift operator. And for to set the bit, I've been use the bitwise OR operator. So this is what we have been discussed in this previous class, right? If you want to be set any of the bit, you have to use the bit shift and set operator. In this case, you have to look out this one. So the GPIO A has been GPIO A of 0th bit. I need to be enabled as 1. Okay. By looking out this, you just see this one. I need to be set 1. This is my motto. Okay. If you are if you are doing a shifting the bit, there is a 2 parameter. That is the first operand and second operand. The first operand is telling what you are going to be set. Okay, 1 or 1 1 0 cross 3 or 0 cross f kind of thing. What you're going to be set. And second operand telling how many times you're going to be shift. Here, I'm going to be set 1 on 0th position. So for that, how many times I'm going to be shift? No need to be shift. I just simply keep it 0. Okay. So this bit which is going towards like this, I'm going to be use the left shift operator. Okay, the bit has been represented in this form. I'm just simply using a left shift operators. Okay, so this is what the thing it is. So that's what it has been completed. Now you enabled the GPIO here. Now you are going to be set the mode, which mode you want to be to. So what the mode it is, because bus has been connected. Okay, you have been complete this work. This is the bus. Through that, with the help of this clock, yeah, enable the GPIO port A. With the help of this port A, what the action you want to be do? Okay, that's what you are going to be see the next thing. Okay, like if you want to be enabled, if, for example, if I'm enabling the timer with the help of this AHB. Okay, for sorry, if you're enabling with the help of this ABB2 with the help of that, same thing I'm going to be do. Okay, I'm just simply enabling the timer 11 or UART1. After giving one clock enabled, it has been enabled. Next, what will I do? What function I do with the help of this UART1 or timer 1? Okay, that's what I'm going to be look out this. So if I want to be work on UART1, timer 1, I just go to this reference manual and go to this UART or timer. If I want to be work on with this timer, I just go to this timer. If I want to be work on with this UART, I just go to this UART. Now I just work on with this GPIO pins. I just go to this GPIO registers. Okay, I just go to this GPIO register. You are going to be read out what is the purpose of all the GPIO registers. Okay, because here it is having the lot of GPIO register. What is the purpose of all the GPIO register? You must be understood this concept. Okay, here I'm just go to this MODER register here. Okay, here what is the purpose of MODER register? So this MODER register purpose is setting the mode. I'm using a GPIO register, a GPIO pin. Here it is, the full form is general purpose input output pin. If you want to be interface with external peripheral and all, you just use this GPIO pin. So what are the configuration is can able to done is here it is. It is input and output pin, but you can configure input, output, alternative function, analog mode. That means you can take a input while you setting 0 0 on that specific bit. We can set the output when you're going to be give the if you're configuring LED motors, because you are going to be give the command. So what are the peripheral you want to be configured as an output mode? You can also do this. That GPIO opens, you can configure as an output mode. And alternative function, multiple function you want to be do, you just set this bit. Analog, if you want to be set, you just set 1 1. Okay, here my case is the LED is configured as a digital output. Right, here I need to set the bit called as a 0 1. So here I got one idea. I need to set the bit called as a 0 1. But where I need to be set the bit? So which pin you have been chosen already? GPIO port A. I already enabled the port A. No need to be set it again. Now my MODER register and all configured. The user want to be work on with this GPIO port A. Now setting the bit, it is going to be understand what the pin they are going to be work on with, and that pin what the functionality is actually going to be do. Okay, here I need to want the GPIO port A of 0th pin and first pin. 2 pin I'm going to be use. So here if you just see this one, so if I want the 0 1, here you are going to be configure MODER 0 and MODER 1. Then what is the difference in MODER pin is, it is the form of 2-bit representation. Okay, it is in the form of 2-bit. Because if you want to configure, they are also given the data in form of 2 bits. If you want to be configure input, you have to assign 0 0. If you want to be configure output, 0 1. 1 0 for alternate, 1 1 for analog. So if I want to configure it as an output, both the place I need to configure 0 1 0 1. Okay, same thing I'm going to be implemented in a program. Okay, here first of all, you are going to be write the address. Okay, so you just directly go to the GPIO-A. GPIO-A. In this GPIO-A, I'm going to be use the MODER register alone. So MODER, here I'm just using a GPIO-A. One of the macronym, I just assign it. And I've been returned the address. What is the address of this MODER? And simply I'm just doing the typecasting here. And after this, I'm just enable the bit. Okay. But here, if you just see this one, if it is a 1-bit representation, if it is a 1-bit, you no need to be using this for loops and all. Okay. You just simply use MODER A, setting the bit and resetting the bit. You can use it for one time. Because of I required the 2 pins I'm going to be use. What are the pins? Port A of 0th pin and the first pin, guys. Okay, so volatile is one of a keyword, guys. It is when you're going to be use it in the program. So you're just simply telling like it is continuously going to be changed. Your values continuously going to be changed. So mostly used in embedded registers because the value is going to be changed. I'm going to be using a port A0 and port A1. If you just see this one, I also made the connection. Yes, these 2 pins I'm going to be used. If I'm only using a port 0, simply use the MODER. Two MODER I'm going to be use register. For one MODER I used for set another MODER for reset. Why? Because the parameter they have been given is you have to set 0, 1 if you want to be configure it as an output pin. Okay, so 0, 1 I just configured 0, 1. This case 0, 1. Okay, I just simply said 0, 1. One pin has been reset. That means 0 means reset. 1 means enabled. That means set. So for that case, what I've did here it is simply use the macro name MODER, GPIO MODER, GPIO MODER. I just use this two name first of all. I just simply returned the MODER, GPIO MODER. One pin is going to be set. Okay, like how I'm going to be represent 0, 1. This is the format I'm going to be implemented in program. So this time one pin is going to be reset means I know what to be used. Reset condition and not operation. If you want to be reset the pin. If you want to be set the bit, you're going to be simply use the OR operator. You just keep it on the mind. This is the logic we are going to be you are going to be implemented. Okay. Okay, I got clear. And then my condition here have been written one condition. So what it is? So 0 cross 3. This is left shift of pin star 2. So it might be confusing. No need to be worried. Here, this is not operator is equals to left shift off. Okay, because it is all the bit which is going through this direction. So I'm just using a left shift. So 0 cross 3 and so pin of star 2. What it is actually mean this? So the parameter is here I'm going to be using a 2 bits. Okay, so here I'm going to be using a two bits because each MODER which can able to holds the 2 bits. So for that case, I'm just using this concept. Okay, if you just simply taking this pin 0, which can holding the 2 bit. Okay, for pin 1, which can holding the 2 bits. Likewise, for each and every bits which can holding the 2 bits. Okay, you might be clear on this point. Okay, so for first, we will come with this loop concept. Here I've been returned the for loop because I'm using a 2 pins. Initialize for of int pin is equals to 0. I'm just initialize the pin which is equals to 0 and the pin which is less than 2. Okay, 0 and 1 I'm going to be used. So less than 2 and pin plus plus, incrementing the value. And inside this, first of all, when the condition has been satisfied, just come to this and you just take this 0 cross 3. So what it is mean that is 0 cross 3. What it is actually mean that is 0 cross 3 is you have to convert it as a binary form. Okay, here you have been returned in this hexadecimal form. It's just simply telling 1 1. Okay, you're just telling like 1 1. And I'm going to be left shift of pin. What is the current pin number? Currently, we are using a 0th pin. Okay, you are just using a 0 into of 2. What you will get? You will get 0. Okay, so you are simply telling the first logic. Okay, shifting the bit up to 0th time. Okay, because this is what you are going to be set. What you are going to be set. This 1 1 you are going to be set. This is going to be tell where you are going to be set. How many times you are going to be set. So 0th position you are going to be set 1 1. Keep it on the mind. It is not going to be set. Before going to be set, you are going to be reset it. That means 1 1 going to be set it as 0 0. Okay. It has been shifted. It has been converted as in 0 0. So you're just simply placing 0 0 on the position of 0th position. That is the first parameter we have been written. Yeah, first clearing the bits at the position of 0. pin A of 0, you have been clear. And then you are just doing setting the bit. How can I do for setting the bit? You have to use the OR operator. Okay. You have to use the OR operator. Okay. So in this OR operator, you have to use 0, 1. Here you have been given the value called as 0, 1. What it is mean 0, 1? What is the binary value of 0, 1? It is 0, 1, 1. Okay, 0 cross 1 it is. What is the binary value of 0? It is 0, 1. Okay. And you're going to be left shift up to pin multiplies of 2. Okay. Pin multiplies of 2. Okay. So pin is still 0 because it is not yet incremented. Okay. It was not incremented till now. So you just multiply with 2, which is 0. So now you're going to be use 0, 1. Okay, you're going to be set 0, 1 on the position of 0th bit. Now you can understood this concept, this logic. So what the logic you're going to be implemented? You are going to be MODER pin of set. Okay, you're going to be set of 0, 1. That means you're going to be set the bit of 1, 0, 1 in the position. The pin of 2. Okay, pin strike of 2. So first of all, in this case, you're going to be using the pin called 0. You just multiply with 2, you will get only 0. Okay, so you just simply taking the 1 and shifting the bit up to 0th position. Okay, that's 0, 1. You just consider it as 0 because it is completely the 2 bits. So it is going to be setting the 0, 1 on the position here. Now it is cleared. Now you are just simply setting the bit of 0, 1 at the position. That is the first thing. And now it is going to be incremented. Pin has been incremented by 1. Now what will be happens? It is going to be changed to 1. Pin 1. Now you just check the condition. 1 is greater than 2. Yes. Now you just come to this. And you are going to be use this logic. Okay. Yeah, just use this logic called as 0, 0 cross 3. Okay. And left shift of pin multiplies 2. Okay. So now the pin value is 1. Multiplies of 2. Okay. So you will get the value called as 2. Okay. So you're going to be multiply with this one. So you will get the value called as 2. So now how many times you're going to be shift the bits? So we will see with this one. Yeah. So it is holding the, if you just see this one, it is holding the 2 bits. It is holding the 2 bits. For that, it is taking a, wait a minute. So it is taking a 2 bits. Second data is just starting from the second position. It is starting from the second position 0, 1. 0, 1. First position you have been taken right and it was incremented. This one first position it has been updated as 1. In second position you have just give the value called as in 0. How you are going to be done this one? Yeah. Here for that case I just incremented the pin. Okay. Now the pin number is 1. The pin number is 1 which I'm going to be multiplied with 2. Now the value called as in 2. And here it is 1. The 1, 1. That means 0 cross 3 is, which is 1, 1. Okay. So that 1, 1 has been resetted because of this knot, which is 0, 0. I'm going to be set 0, 0 at the position of 2 and 3. Okay. When you're going to be shifting the bit, it is going to be 0 is going to be updated on 0 and 3rd position. Okay. Now what you are going to be do? You are going to be set the bit of 0, 1 as well as for your another bit. So now I'm going to be do the same procedure. I'm just simply holding 0 cross 1, which means 0, 1. And I'm going to be left shift off that second position of the bit. Now it has been updated called as 0, 1. So now this position bit has been updated as not 1 0 guys, it is 0, 1. Sorry for this one. Sorry for this mistake. Okay. Now it has been updated called as 0, 1. Okay, because if you want to be configured as an output, it is going to be updated as a 0, 1. Okay, now it is going to be updated as a 0, 1. So we are going to be shifting that bit 0, 1. Okay, so 0, 1 is going to be shifted to this position. Okay, you got clear up to this point, guys? If you got clear, you just post clear message on the chat box. Simple thing, guys. I'm having 1. I'm going to be shifting that bit. Okay, which can holding 1. Okay, I'm going to be connected with this first pin. So it is holding a 2 bits. So I'm going to be shifting the bit 0, 1 at the position of second. So it is going to be updated like 0, 1. Okay. And last but not the least, guys, now we are going to be do the actual work. Okay. So if you just see this one, binary count blink going to be, we are going to be implemented. So you have been using a count 8. So what do you mean? So what is the count bit 8? That means it is a 2-bit of data. Okay, your bit's going to be 0, 0, 0, 1, 1, 0, 1, 1. How many things? 0, 1, 2, 3, 4, 5, 6, 7, 8. Totally, it is going to be counting 8 times. That is what we have just assigned 8 counts. So while 1 means it is infinite. If you're using a for 1, it is an infinite. While if you just put double semicolon, double semicolon, it is do nothing 1. So while 1, it is continuously going to do this work. Okay. And here I've used another for loop. Okay, for to be blink the LED. This is just for configuring the pin as output pin. Okay, here you just actual thing you're going to be implemented, like you're going to be blink the LED. Okay, so if I want to do the output function, because we are fully work on GPIO only, we are not going to be go to this another one. So you just look out this one. Now I successfully set the mode. It is going to be configured as an output. In output, you are going to be find it out the output data register. If you are using an input mode, you just go to this input data register. If you are going to be using alternative function, you just go to this alternative function. Okay. Likewise, it is going to be output. You are going to be go to this output data function. Okay. Output data register. Here, sorry guys. In this output data registers, this is input data register. This is output data register. Which pin you have been connected? You have been connected 0 and 1. Okay, 0 and 1 you have been connected. Okay, so to enable this one, so to giving 1. Okay, so to enable this one, so when we do like enabling the bit, it is going to be on. I'm just doing on off continuously. Okay, so for that, how many bits for simply I've just taken the uh, 2 LEDs. Okay, I'm just to show the connection also, guys. You can easily understand. Okay, so the 2 LED simply have been taken, guys. So the 2 LED, one which have been used the 330 ohm, another one which have been used the 220 ohm. Okay, and the pins have been taken a port A of 0, port A of 1, and another which have been connected. The anode which is connected with the uh, GPIO pins of port A0, port A1, and another cathode has been connected with the ground. Okay, both has been connected to the ground. The pin, the LED is going to be toggle in this form of 0, 0, 0, 1, 1, 0 kind of logic. It is going to be implemented. Okay. So the first 0, it is going to be initialized with a 0. And here in this scenario, we are just simply doing off the LED. Okay. We are simply doing the off the LED. So how it is actually going to be do this function? First of all, you are just taking the pin 0, okay, and the pin 0 and pin 2 has been configured. Now you just start to be count the things. First of all, the 0, okay, that is a LED 1. You just using a 2 bits, okay, for each and you are going to be configure this one, okay. You are taking LED 1 and you are going to be taking LED 2. Okay. So first of all, both the pin is going to be get off. Okay. For that, I just used this concept called as an F means. So don't be confused with whenever they have been used the concept called as an F, E. You just simply convert it as a decimal value. Just simply convert it as a decimal. F means it is X decimal value. The full form is 1, 1. Okay, 1, 1, 1. Full form. You're going to be get this value. This case, I'm just having this 1, 1, 1. I'm just doing this not operation. That means completely get 0. Okay. Then why we need to be do this operation and with this 1 means, so for some cases, if you are simply using a 0, 1, 0, even though it is not, it will be providing some value. Okay. When you just add with some operation, and with any other things, like if you're just trying to be and with this one, it will be completely 0. It will be completely make it 0. Okay. It will understood this one. So first of all, I just make it the LED become 0, and then it is going to become 1. First of all, 0th LED. So which is coming, so the 0th pin, the port of 0. Pin 0, pin A of 0 which is coming. So here you are going to make it 0, 0. You are going to be make it. And if you want to be enable the pin, the ODA, you just take the count. The count means count is 0. Okay, this is the initial stage, guys. Okay, initially you are just simply reset the pin. You are not going to be on the pin, just simply make it 0. Okay, it's off condition. Now you are going to be playing the role of 4 bits, like LED 1 and LED 2 is there. We'll clearly see this one. I'm having a LED 1 and LED 2. 2 LEDs are there. It's going to be work 0, 0, 0, 1, 1, 0, 1, 1. The way, okay. The first of the scenario is the count. You just take the value called as in count, which is 0. And you just do with this operation called as an F. So most probably checking condition. This is completely for checking condition, guys. Checking condition, I already told you, you have to use the AND operation. Okay. So here I'm just go to implement it with this high value of FF. FF means which is 1, 1, 1. Okay. I've just taken this value and with, I'm just going to do with this and with, just simply and with the first. What is the value of count currently, which is 0? So what is value of 0? 0, 0, 0, 0. It will be provided the 40. So it is provided the value called as 0, 0, 0. So it is 0. Now the LED 1 is 0. Okay. At the same time, you are going to be check for the second LED. Okay. It is going to be what it is actually going to be 2. Okay. So then you are going to be incremented 1. Okay. You are going to be incremented by 1. So it is not going to be considered LED 1, LED 2. So just by the count value. Now it is going to be considered as an 1. Okay. So you just simply see this one. This is 0 count, 0 logic. Next count 1 logic. You are having a 0 of FF, you're going to be AND with, that is 1, 1, 1, 1. You're going to be AND with just simply write 1, 1, 1. Okay, you don't confuse it because this is same for all. What is the binary value of 1, guys? It is 0. I mean 1. Okay, 0, 0, 1, 1. Okay. If you just AND with this one, you will get 0, 0, 0, 1. Okay. Now it is going to be get on. Okay. But here the scenario is we are not going to be using the 4 bits. We're simply using a 2 bits. So don't go with this one. Just simply using a 2 bits concept. For that, we just simply taken a 0 cross F. First of all, count to 0. It is go to and with the 0, 0, the value it will be provide 0, 0. Both LEDs got off. And I mean LED is off. Next it is incremented by 1. Just simply do with this one. It is going to be provide the value of 0, 1. And next you are going to be get the value for count 2 you are going to be made. And you will get the value of 1, 0. And then you are going to be add on these things. Okay, it is going to be incremented. And now it will be provided the value called as, this is the value of 3, binary value of 3. Provide 1, 1. By this logic, so when it is giving 0, 0, both LED is off condition. If it is give 0, 1, one LED is on, another LED is off, off, on, off, on. Based on this, it is going to be works. Okay. So now we will do this work, guys. What I'm going to be do is, I'm going to be connect to the LED. I'm connect the board with my laptop. So okay, when I'm going to be connect this, so I can able to see this, it is completely blinking by the logic. But I'm going to be teach you that because I already dumped the code, guys. How to rectify whether my code is right or wrong. So you just right click it and you just give build project. So when you're going to give build project, there is no errors and there is no warnings. Will good to go. And right click it and go to this debug as and debug configuration. And after what the project you want to be enabled, go to this and go to debugger. Make sure you should enable the serial wire debug because STM32 which is having that, and STL. And enable this and enable the serial wire viewer and debug. So after you have been given the debug, so it will be start to do it from the scratch. You can see this concept. One is white, another one is green. Okay, it has been successfully done this procedure. If you just give resume, yeah, it is working that logic. 0, 0. Both are off. One condition. Second 0, 1. 0, 1. So another 1, 0. 1, 0. At the time, both are get on. 1, 1. Can you able to see this one, guys? Okay. Okay. Got clear, guys? Got clear? You don't confuse with this pins and this counts. This pins, it's just a variable only. It's just a variable like MODER register, it can holding a 2 bits. That's what we have been enabled. That is a 2. Okay. Here count means I'm having a 2 LED. I'm implementing the logic of 2-bit data. If you want to be implemented the 8-bit logic. Okay. If you want to be implemented the 8-bit logic,